Welcome to the episode of my Linux driver tutorials. Today I want to show you how to write a Linux driver which is compatible with the Industrial I/O subsystem. But what is Industrial I/O? Well, the Industrial I/O subsystem is a subsystem in the Linux kernel to make it easier to write drivers for various sensors, ADCs, DACs, accelerators, gyroscopes, and so on and so forth. Industrial I/O offers a standardized interface to userspace, which is, for example, accessible over the sysfs. And in today's video, I will write a simple Linux driver for an Atmega I2C ADC, which is compatible with Industrial I/O. So here on my camera you can see my setup. So here I have an Atmega microcontroller and I've connected this variable resistor to it. And now I can read out the value of this resistor over I2C. So let me show you how to do this. So if I scan my I2C bus, you can see I have a device at address 10 hexadecimal. And on power up, the device starts in power down mode, so it doesn't read out the value of the ADC. If I want to check the current mode, I have to write out 11 hexadecimal over I2C to the device, and then I can read back the current state. So I can do this with I2C get. I will read from bus 1, the address of my device is 10 hexadecimal, and before reading I want to write out 11. And you can see the current value is 0, which means power down mode. So let me set the mode, so the device starts to read out the ADC value, and I can do this with I2C set. And before I have to write out 22 to set the mode, and then I will set the mode to 1. Okay. So now you can see this LED has turned on, and this indicates the device is now up and running, and I should now be able to get the ADC values. And to get a value, I have to write out 55 first, and then I have to do an I2C read. I will do this with this command, and you can see this is the current value of my adjustable resistor. So if I change it, you can see now I have a different value here. And in today's video, I want to write a driver for this simple Atmega I2C ADC. But first, I will set this in power down mode again. So the LED is now off. Okay, so let me cd into my Linux driver tutorials folder. And I will use this kernel module, which is a simple device tree I2C hello world program as a template for today's video. So let me copy this and I will create a new folder I will call 25 device tree industrial I/O. And now let me cd into it. So what you can see here is, here we have a folder containing the source code for the Atmega I2C ADC. I will replace this with my current code. Then here we have the source file for our Linux driver. Here we have a device tree overlay because I will add this device over the device tree. And here we have a make file to build the device tree overlay and the Linux driver. So the first thing I will do is I will rename dt-i2c.c to dt-iao.c, and I will change this in the make file as well. Okay, and now let's take a small look at the device tree overlay. So here we are adding a new device to I2C bus 1. The name of the device is my ADC, and it is located at I2C address 10, and the compatible string is bright light my ADC. We will find this in the kernel module. Okay, so now I will open up the Linux driver source code, and the first thing I will do is I will remove some stuff here. So down here I have an procfs entry, but I won't use procfs here. I will only use the IIO subsystem. Here we have a read and write callback, so let's remove these two lines, these two functions here. Here we have the procfs file operations, we don't need them here too. And down here we are creating the procfs file, which we don't need any longer. And down here we're removing the file, so okay. Now we have a clean canvas to play around with. So the first thing I will do is I will include some headers. The first header I will include is linux/iio/iio.h, and the second one is linux/iio/sysfs.h. Okay, and then I will add some defines. So the command to get the current state of my device is 11. To set the state it is 22. And to get ADC val it's 55 hexadecimal. Okay, and I will change this a little bit here, so I will declare a new struct. I will call my ADC. Then the arguments of this struct are the pointer to our I2C device. Okay. So down here we can see the list of devices we're compatible with in this driver, and it's just brightlight my ADC. Down here we have the ID tables, which is just my ADC. Down here we have our I2C driver struct, where we are filling the probe remove function, the ID tables, and the driver data in here. And down here we have the probe and the remove function for this device. So the first thing I will do is I will replace dt_i2c with dt_iio. Okay, and now let's add our device. So the first thing I need is I need a read function. I will call it my ADC read raw. And this function will be called whenever I want to read out the value of the ADC. The arguments are as follow. The first one is the industrial IO device. I will call industrial IO device. The second argument is from the type IO gen spec. It's a const pointer, and I will name it gen. This is the channel because IO devices can have multiple channels. For example, if you think of the BMP280 sensor, which can read out the temperature and the pressure, and you can use the same driver, but you just add a channel for the temperature and a channel for the pressure, for example. And this is what channels are, but we will just use a single channel for our simple example here. Then the next argument is an integer pointer to the value we have read out. Then we have a second value integer pointer and a mask field. Okay, and now I will declare a new pointer variable from the type struct my ADC, and I will call it ADC, and I will set it to IIO priv in the IO def. So here I'm getting the device data, so I have this pointer here. Okay, now I check. Behind the mask I can see the operations, and this read function could be called with multiple operations. But I will only support the IIO channel info raw method, which is just a raw read of the sensor's data. In case the mask is something else, I will return error invalid here. And in case of success, I will return IIO value int because we have a new integer value available at the end. Okay. And I will need a second variable here. I will call read for return value. And what I will do is, to get the current ADC value, I will call the function I2C as mbus read byte data. I want to read from ADC client. And before reading, I want to write out the command get ADC value. In case this value is smaller than 0, an error occurred. Reading ADC value. So I will print out this error and I will return the error code here. And in case this worked, I will set the value pointer to the value we have written here. And that's it. So the next thing we need is we have to set up the channels. Therefore, I will create a new const struct from the type IAO chan spec, and I will call it my ADC channels. And this is an array because we can have multiple channels. But here in my case, I will just need one. First, I have to specify a type, and for an ADC, I will use IAO voltage. And the second argument I have to specify is info mask sequence bit IAO channel info raw. So this entry here means please create a new file in sysfs, and I want to have a file where I can read out the raw value of my ADC. Okay, and this is the only argument here in this channel. So I have just one channel. So in the next step, I will create a new struct from the type IAO info, and I will call it my ADC info. And here I have to pass a pointer to my read function. So read raw is my ADC read raw. Okay. And now all we have to do is we have to add this IO device in the probe function. So let me go down to the probe function. Up here I will need some variables. So first I need an IO device, and I will call it INDIO device. And then I need a ADC pointer, and I will call it my ADC. Okay. So first, and I will need a return value. Return. Okay. Good. So now I will create a new industrial IO device with a managed function. So I will call defm IAO device alloc. I want to bind this to my I2C device. Okay. And in case this didn't work, I will print k IAO error out of memory. Will return error no memory here. Okay, in case this works, I will set the data to with IAO priv in the IO def. So here I'm allocating memory for this ADC struct here, and then I can set the client to client, so I have access to my I2C device later. And now I have to do a little bit of setup. So the first thing I will assign is a name. Here I will use the name in the ID table, which is my ADC here, because if I would have multiple names here, it would choose the correct name for the current device. Then I have to set the info, which is my ADC info. Then I will set the modes, and the mode here is Industrial I/O Direct mode. This mode means over sysfs we can always read a sample at any given time, because for example if we couldn't read in a specific time we would use a different mode here, but here in my case this mode is just okay. The next thing we have to set are the channels. And here I will use my ADC channels. And then I have to specify the size of the channels, so number channels, how many channels are available. So I could type a 1 here, or I could use the array size macro and use my ADC channels here once again. And that's about it. Now I will set the ADC to power up mode, up mode, let's call it power up mode. I can do this with I2C. So I2C is bus write byte data. I want to write to my client, and I would use I will write out the command set state, and I will set the state to 1, and now my device should be up and running. And in case if return is smaller than 0, an error occurred. So let me copy these 3 lines here. Could not power ADC up. Now return -1 here. Okay, and here at the end we have to, I will use defm IIO device register. With this call we are creating the sysfs files for our industrial I/O device. Okay, so that should be it. Let me try to compile this module and let's see how much mistakes I've made. Static. Okay, I will pause the video for a second and then I will come back. So the first error was easy. I just have to remove the static here because we're inside of a struct. Okay, and the last error is this is not sequence. Sorry for this. This is separate. Okay, so separate. Okay, I have a typo here now. Separate. Okay, so let me try to build it again. And this time it should work. It looks good, and we've also built our device tree overlay. Okay, so the first thing I have to do is I have to load the driver for the industrial I/O subsystem. I can do this with sudo moprop industrial I/O. Industrial I/O. Okay, so now this module is up and running. And then I will use our device tree overlay, load it, so test overlay DTPO, and now I can load my kernel module. And you can see the device is now in power up mode. And if I look into sys bus IIO, I can find device. I can find a device here. So let's look what's inside this folder. So here we have the in-voltage raw folder, and to get the value, what we have to do is we have to just read out this file here. Okay, and of course I have to use cat. Okay, so this is the current value of the ADC. If I adjust it, yeah, you can see the value is changing. So this works. And if you want to get the name we've applied, you can look into off node name, and here is the name, which is my ADC. Okay, great, so this seems to work. We have successfully written an industrial I/O compatible Linux driver for this small Atmega I2C ADC. So I guess that's it for today. I hope you've enjoyed the video and learned something. If you want to support my work, you can buy me a coffee on buymeacoffee.com/johannesforlinux. So that's it for today. Thanks for watching and goodbye.